come to the University of Delaware to study. So this has been a really nice end to my career, having a great grad student. So this is Shem Elias from Tanzania. He's going to talk about his program on baby ginger.
Thank you, Dr. Bruno. Hi, everybody. My name is Shem. I'm a master's student in the Plant and Soil Science Department, and currently we're running a ginger project where we're trying to explore the potentials of growing baby ginger in the mid-Atlantic region of the US. So pretty much, ginger is a spice and medicinal crop which is grown on the tropics and subtropical climates. So it takes 8 to 12 months to get a mature ginger. What we're trying to do is we're trying to see if it can really adapt into the mid-Atlantic region, but not to grow it for maturity, full maturity. We're trying to cut half the growing period to the immature version of ginger. So ginger on its own is a nutritious and medicinal crop, but there are claims that the potential of its nutritional values and medicinal values increases once it's harvested immaturely. So we're trying to confirm that by growing it in our region, but I'll also replicate these trials back home in Tanzania. So we started raising these seedlings that you're seeing here from March in Newark in the growth chambers, where we have ability to control temperature and humidity. So we kept temperatures pretty high because ginger likes very warm and humid conditions. So we kept temperatures very high, around 27. That should be somewhere around like the early 90s or the late 80s, where it grew. So it grows very slowly. It took around 2 months to begin germinating, sprouting, and then full development. I brought it to the field around May when it was like warm outside. So the thing is, apart from us growing it half the time, where it's like 4 to 6 months, we're also trying to see if we have varying irrigation frequencies, it's gonna affect its biochemical composition, growth, and development. So pretty much, we normally consume ginger rhizomes, which I can show you. Here are this is the old rhizome, which is attached to the new rhizomes which are developing. Then we do have the roots, we have the pseudostems, thank you, Dr. Gordon, and we have the leaves. So we normally consume the rhizomes, but we do not consume any other plant parts. Why don't we consume the leaves? Why don't we consume the roots? Why don't we consume the pseudostems? So apart from me being able to do the experiments with varying irrigation frequencies, I'm also trying to see how the allocation of these spice compounds is going to be in the plant itself. How much of the spice compounds are going to be in the leaves, how much in the pseudostems, how much in the roots, how much in the old rhizomes and in the new rhizomes. So at the end of the day, you don't really need to wait for 6 months for you to approach your ginger plant so that you can have the benefits of growing ginger. You can be continually harvesting the leaves and still get the potentials of ginger as a spice and medicinal crop. So we do have treatments where we apply excess amount of waters. We do have treatments where we apply less amount of waters. So this concept applies to some of the crops differently, because some crops like watermelons, pineapples, and citruses, when they get too much water near harvesting, they become like diluted and mild sweetness. While at the end of the day, water is important for crops to grow, get a lot of resources to do like the photosynthesis and accumulate results in the storage organs. So for crops which have ultimatum before harvesting, they really want the drought stress for them to have added sweetness. Ginger is kind of different because it really does not have a ultimatum. It continues growing once you provide it good environment. So we're trying to see like which is the stage of growing where it like sensitive to water by monitoring the treatments which have water stress and also monitoring the treatments which don't have water stress. So it's going to take us like till October or something to complete this trial, but at the meantime we'll be having a lot of laboratory trials to confirm and assess the concentrations of these compounds in all the plant parts. So it's going to be analysis according to time, analysis according to treatment, and analysis according to plant parts. And for this project, I'm working with Ian Kelly. There he is. He was lucky enough to get an internship where he's doing the open field trials both here in Georgetown and in Newark, and I'm doing the tunnels and in the greenhouse replications.
Shem, talk about the other thing you're looking at is 3 different growing conditions. You're growing it in the greenhouse, in hydroponics, in high tunnels, and also in the field.
Yes, I almost forgot that. So, the other thing is that this project is centered around sustainability. Ginger takes a very long time to grow. That means it uses a lot of resources. So us cutting half the production cycle, basically or theoretically, we are also cutting half the resources that are required in terms of water use, time, fertilizers, manpower, space, etc. So we do have treatments where we have 100% of soil moisture, where we place the plants in hydroponic systems so they are constantly exposed to nutrient solutions. And so far what we've seen is the more we provide enough resources, the waters and the fertilizers, ginger grows profusely. There's so much chlorophyll content in the leaves, etc. And when you stress it, also the growth is affected. It grows pretty slowly. So there's obviously significant difference in growth from what we've seen so far. Treatments which are exposed to hydroponics perform better compared to treatments which are under severe water scarcity. We don't know of the biochemical composition though, but for the terms of growth and development, the hydroponics plants grow and develop much faster. So we're having these treatments in Newark. Newark soils are pretty much clay soils, so they hold water for longer periods of time. And we also have these experiments here in Georgetown where it's like sandy soils. So the sandy soils don't really hold water that long. That means there's quick drainage. That means the adherence to treatments is even more here in Georgetown compared to Newark. But also in Tanzania, we're having loamy soils over there, so it's kind of falls in between the clays and the sandy soils. So it's going to be interesting to replicate it back home and see what the results are going to be like. And pretty much I'm doing it open field where I'm going to have interruptions of the rain, and then in the tunnels where I'm going to have control of the irrigation, so I only apply water when the soil moisture has depleted. And then I'm also going to have I'm having replications of these experiments in the greenhouse where it's even more controlled, where we can pretty much control the amount of soil moisture or the amount of media moisture that is prevalent. So in the greenhouse trials, I'm trying to use soilless media, mixture of compost and rice husks at 1:1, pretty much just to make it even more favorable for ginger to grow and get sufficient data in a short period of time.
So right now, this experiment's in mid-growth. They will be probably twice this size by the time they're done. The other thing on baby ginger you'll notice is that it doesn't have the papery covering on the outside, so basically you can cut it up and use the whole thing, which you don't have to peel it like you would regular ginger. And the price is really high for baby ginger versus regular ginger. It's like 8 times the price right now. So, well, of course, we're not going to hold if we keep producing this much ginger, but still, right now, because it's a novel item, it's going to be a much higher price. Now, the storage ability is much lower. Of course, you're not going to store this for as long, probably 4 weeks, right? About 4 good weeks, 4 to 6 weeks. Compared to ginger, you can store for months and months when it's mature. Any questions for Shem? Yes?
Yes, they're pretty similar with turmeric. They all come from the same family, but the thing is, turmeric is mostly used for coloring. So there are no intensive studies on the potential, on the medicinal and pharmacological potentials of turmeric as compared to ginger. But pretty much all the growing conditions for turmeric and ginger are pretty much the same. The thing is, ginger has been so much exploited on its medicinal potential, and there are claims that is anti-tumorous, anti-cancerous, anti-inflammatory, anti-nausea, anti-diabetic. There are a lot of studies about the potentials of ginger as a medicinal spice.
Yeah, if you eat ginger, you'll live forever. So, all right.
So when is the research going to be up on your
When will this be finished? Shem has,
February?
like this trial is going to go until fall, October. The one in Newark, he's almost finished with the one in the, finished with the one in the greenhouse. He's going to start a second one in the greenhouse, and he's almost finished with the one in the tunnel up there. So we'll have a big slug of data for you all to see by Ag Week for sure. And then he's got to go home and grow it in Tanzania too. So it's been such a pleasure working with him. Hardest working person I've ever known. Excuse me. Yeah. All right.
Yeah, pretty much. Something else I want to mention about ginger is about ginger and the baby ginger project that we're doing. So for the US, we normally have a small tropical window, I could call it, where it begins like the end of spring to the early of fall, where like it's so warm, where we can grow these tropical crops. So we cannot grow ginger 8 to 12 months because it's very sensitive to frost, very sensitive to winters, and very sensitive to cold conditions. So even the moment I transplanted the tunnels in Newark, they got cold stress and they were like struggling to overcome the cold stress. So we cannot really go for mature ginger in the US, and pretty much data shows that 80% of ginger that's consumed in the US is imported from outside. So if we are able to produce the baby ginger, that amount of fund which is going for importation of ginger is going to be available for farmers who decide to produce it in here. So that means even more economic streams for the farmers who will engage in production of ginger. And it pretty much does well. Here in Georgetown it's doing pretty well. In Newark it's also doing excellent. I mean, I couldn't imagine when I did destructive measurements about 2 weeks ago, because the return from ginger, once you plant 50 grams, at the end of the day you expect to have around 500 grams. So in Newark we're not even really 5 months, but we already have more than the return. We planted around 50 grams and right now we are around 600 grams, 610, 515 for the treatments which receive excess amount of waters. So it drops like that from like 600, 480, 300, 100, and others are like 70 grams. So it's 50, 4 months, now we're 70 because of water stress. We don't know biochemical composition and concentration yet because I've not really engaged in the laboratory analysis. But so far I could say the more you give plants water, the more they grow. But what do they have inside? I really don't know for now, but
you will know.
Yeah, pretty much.
Yeah, you touch the soil.
So again, a wonderful program where they're able to bring students from East Africa here to the U.S. to learn at the University of Delaware. And we're so lucky that Boral family does this for students out of that part of Africa.
What's your market?
Anybody that, you could think anybody who wants to use ginger. Of course, my wife uses a lot of ginger. So who here uses a lot of ginger? Yeah, well, there you go. So again, you have a ready market just for folks who use ginger. You have a market for medicinal use, so that could go to people who are making ginger whatever. And then you have market to the processing industry too. Oh sure, yeah, it would go. Produce terminals would be a great place to try to market this.
Now you say that the baby doesn't have a shell on it. You can eat it right. I saw it.
Right,
You could eat
no
it right
shell.
away. So you'll just harvest it and refrigerate it when you send it out to sell?
Yeah, so it's mostly harvested, then kept in areas with high humidity. If you cannot get low temperatures, or if you can lower the temperatures, high humidity, so you can have like a plastic bag or a Ziploc bag.
Just bag it.
Yeah, you bag it and then you close, to prevent escape of moisture from inside the bag. But the thing is, we can also process ginger, and it can be processed into milled products, such as dried and ground powdery forms.
Right.
We can have like some syrups, or we could have like some ginger which was like put in excess salt, some ginger sliced and put in excess salt so that it can
There's a
stay
lot
for
of
longer
things
periods
you
of
can do.
time. Yeah, so
To
the baby
stabilize
ginger
it.
has so much water content, so it like from 200 grams you can end up with like I don't know 10 grams, so that's pretty
not
low.
bad.
So yeah,
For a
it's not that
spice.
bad. So that means even the prices increases. We're having multiple stakeholders involved on all these commodity chains. That means even more economic streams for people who want to engage in the value chain or commodity chain processing
Right.
ginger. Yeah, so we
Sounds
also
good.
have some leather bars, ginger snacks, ginger
Yeah, yeah.
beer. Yeah.